All right, page 33 in your textbooks, you had an extra weekend day, Labor Day weekend, to get this done. So hopefully you did this in study hall or did this Friday, so you didn't have to worry about it yesterday. Trust you had a good Labor Day. Most of the football games were sad because nobody played anybody good, except the Colorado TCU game. That was a good game, and FSU LSU was supposed to be a good game, but the Tigers were so infatuated with their air-conditioned helmets that they forgot about how to play football, and so the Noles cleaned their clock in the second half. But anyway, I digress. Page 33, you did 1 through 8 at the top and 1 through 9 at the bottom. Good. Quickly, Jalen. Question mark. Oh, I know why. Good. What is this question mark nonsense? Some people. All right, and then is there a 1 through 9 at the bottom per chance, or is that down here? You had 1 through 8 at the top and 1 through 9 at the bottom? Oh, okay. Did not. All right, let's go ahead and take a look at our homework. We're going to start with the 1 through 8 at the top of the page. You're finding the greatest common factor of those groups of numbers, and admittedly, some of these cases you could probably just figure it out, but for the sake of showing and reviewing, we decided to use prime factoring to help us here. So the key was to prime factor the 9, and there's really only one way to prime factor the 9. You're going to split the 9 into what, Luciana? 3 times 3. And then for the 15, there's only one way to prime factor that, Bryson.
3 times 5.
3 times 5. And the key is to see, what do they have in common? Well, class, the only thing they have in common is a 3. So what's the greatest common factor?
3.
3. Again, could you figure that out without the prime factoring? Probably. Let's look at number 2. We had a 20 and a 32. Well, when you factor the 20, you probably, if you're doing the factoring tree, you split it into 4 times 5, but then the 4 splits into 2 times 2. Or you could use the division of primes, where you do 2 and 10 and then 2 and 5. Either way, you should have gotten 2 times 5 for the 20. The 32 was a fun one, Sam. What did you get for the prime factors of 32?
2 times 2 times 2 times 2.
Times 2. Should have been 5 of them in there. 5 of the 2's there. But what do they have in common, class? 2 2's. So if they have 2 2's in common, 2 times 2, class, is 4, and that's our greatest common factor. Again, could you have figured that out by thinking, hey, these were both on our 4 times tables when I was in elementary school? Yeah, you probably could have, and it would have worked. But just make sure you don't mess that up. Look at the next one, 12 and 90. Now, 12 isn't too bad. How did the 12 prime factor? Paige?
4 times 3.
Well, initially 4 times 3, but then the 4 splits into
2 times 3.
So we have a 2 times 2 times that 3 that you said. The 90's fun. Let's do this one together really quick, Jalen. 90, probably the most natural way to split a 90 is to say
9 times 10.
9 times 10, but then the 9 splits into,
3 times 3.
and the 10 splits into,
2 times 5.
and so if we were to list them in order, we'd have a 2 times 3 times 3 times 5. Now, what do they have in common, class?
3.
A 2 and a 3. So what's the greatest common factor, class? 6 is our greatest common factor. For number 4, what did you get for the GCF? Corey?
12.
12 is correct. For number 5, what did you get for the greatest common factor, Elaine?
5.
5. For number 6, what was the GCF, Ben?
Number 6? 4.
4 is correct. Number 7. This one gave one of us some trouble here. If we wanted to prime factor the 13, what would we split the 13 into, class? Nothing. It's already prime. Its only factor is a 13 and 1, which we don't write the 1. What about 39? Well, what of those numbers do we know has to be in a 39, class? 3, because the sum of the digits is divisible by 3. And if you divide it, you get 3 times 13. So what's the greatest common factor, class?
13.
13 is that greatest common factor. Number 8, if we had a 36 and a 45, how did we prime factor the 36? Kirsten?
12 times 3.
Well, initially 12 times 3. How did we factor the 12?
2 times 6.
2 times 6. How did we factor the 6?
3 times
3 times 2. So we should have ended up with a 2 times 2 times 3 times 2 when we prime factor it. What about the 45? Michael? What are the prime factors of 45? Is this from number 8 on your homework? Prime factors of 45? Let's just do it real quick then for sake of time.
9 times 5.
Let's put the 9 into...
3 times 3.
Alright, so we got a 3 times 3 times 5. Class, what do they have in common? 2 3s. So, what's the greatest common factor, class? 9. What if we'd had the number 8 and the number 15? If we prime factor the 8, anyone, what do we end up with?
2 times 4.
Well, prime factor, so
2 times 2 times
2 times 2 times 2, right? What about 15? There's only one good way to factor it.
3 times
3 times 5 plus, what do they have in common?
Nothing.
Nothing. So what's the greatest common factor? 1. Do you remember how we described from last week, and this wasn't something I emphasized, but I did go over it, how we described the numbers 8 and 15 since they have nothing in common except for a 1. Jalen? There was 2 ways we could phrase it. They are prime to each other. Prime to each other. Or you might have remembered seeing the term relatively prime. Numbers that have nothing in common, except for 1, of course, are called relatively prime. Or, class, we could say that they are... We're still waking up for the weekend. Class, how do we describe numbers that only have a 1 in common?
Prime to each other.
Prime to each other is correct. Questions on the 1 through 8, finding the greatest common factor. How many got all of them right? Yeah, all of them. Several of you. Anyone just miss one? Just missed one? A couple of you? Questions at all? Let's drop down to the bottom of the page now and take a look at this review here. Number 1. This is kind of stupid, easy, but really wordy. What is the name for a straight line that is broken into equal parts, numbered, and extended infinitely from left to the left and to the right? Who figured out what they were talking about here, Sam? Not a fraction line, Luciana. Number line. They're just talking about a number line. Like, that's a really wordy way to describe the number line, but whatever. Number 2. What is the value of, what did you put for letter A, Jalen?
7/10.
7/10. So what about letter B, Bryson? 2. Number 3. Ordering those numbers from least to greatest. What did you put for that? Paige?
Negative 3 2/5, negative 2.31, negative 1, 4.7, and 5.
Excellent. Again, just so that we make sure everybody can hear. Negative 3 2/5, negative 2.31, negative 1, 4.7, and 5. On the number line for number 4, you were supposed to plot these points. Should have looked something like this. Let me see here. We go up to 7 and negative 7. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6, 7. And I'm not going to label all those numbers because I'm lazy. For negative 6, of course, you should have just put a dot where it said negative 6. For 3.4, should have gone between the 3 and the 4, but closer to the 3. Just barely, though. Barely closer to the 3. For 2, of course, you put the dot at the 2. For negative 1 and 1/7, you're going negatively. This would be negative 1. Which direction do I go to get to negative 1 and 1/7, class? Left, just a tiny little bit. This way, past the negative 1, and then 0, of course. Do anyone remember what we call the 0, that number?
Origin.
The origin of the number line. Number 5, determine which of the following numbers are prime. Which ones of those are prime, Kirsten?
13.
That one is, but there's actually one more.
31.
31 is also prime. Good. Number 6, is 28 prime, composite, or neither, Michael? He's looking at my bulletin board dreaming about pi instead of paying attention. What? Composite is correct. Which counting number is neither prime nor composite? Corey? 1. What's the other number that's not prime or composite, class?
0.
But is that a counting number?
No.
No, but it is a whole number. It's also an integer. It's also a rational number. Let's see. Which of those things is the base? Which of those 2 numbers is the base, Sam? The 6th. What do we call the 25, class?
Exponent.
Exponent. And for number 9, we were supposed to expand and multiply. What do we get for the expanded form, Ben?
200.
No, not the answer yet. Just the expanded form.
3 times 3 times 3 times 3 times 3.
Good. And then the answer is?
243.
243 is correct. Good. Any questions on the 1 through 9 at the bottom? Any questions at all on 1 through 9 at the bottom? Anyone perfect on 1 through 9 at the bottom? All right. Go ahead and set that, actually just flip over if you went to page 40. Flip all the way to page 40. There's just 2 review questions at the bottom of page 40. Do 21 and 22. Page 40 at the very bottom. Take about, I don't know, a minute and a half to do number 21 and 22 in the review section at the very bottom of page 40. Several people already finished. Give it just a little longer. 21 and 22. Below the hot dogs. How many hungry? How many did not have breakfast this morning? Oh, I'm so sorry. I can't make it without breakfast. I'd be grouchier than I am now. If you think I'm mean now, just imagine me without breakfast. That's mean. Hangry, I think, is that the term for it? Don't be hangry, grab a Snickers. Snickers satisfies. Or something like, isn't that the commercial they used to have? I haven't seen a Snickers commercial in a while. But I know they still have Satisfies on the Snicker bars, though. That goes back. That was when I was in college. They had those. It's almost 20 years ago now. They haven't changed their advertising much. I mean, if it works, why change it? All right, let's take a look at these together. Number 21. Are these numbers prime or composite? Letter A, class. 22 is?
Composite.
Composite. Letter B, 37 is?
Prime.
Prime. Letter C, 51 is?
Composite.
Composite. Which of those numbers is a factor? 3, right? 5 plus 1 is 6. That means you know there's a 3 in there, even though your 3 times tables didn't go up that high. What about 83, class?
Prime.
Prime. None of those divisibility rules is working for 83. It is one of the few prime numbers up that high. Number 22. For 9 and 12, what did you get for your greatest common factor? Kirsten? 3. And for 16 and 72, what did you get for that GCF? Elaine?
8.
8 is correct there. Questions on either of those? Any questions at all? GCF. We feel good about greatest common factor. Going once on questions. All right, let's talk about another concept besides common factors, and that's this idea of multiples. Laying feet down. If we were to talk about multiples of the number 2, well, a multiple of 2 is anything with a 2 in it. Okay, so for instance, class, 2, 4, 6. Say some more multiples with me.
8, 10, 12. 14.
Etc. Do you understand the list could go on literally infinitely, correct? Well, let's think about multiples of 3. Say them with me. 3, 6, 9, 12. Continue.
15, 18, 21.
And then that list again could go on infinitely. What about multiples of 6? What would be some multiples of 6 here, class? 6, 12, 18, 24, 30, 36, 42. And again, that list also could go on infinitely. How about multiples of 11? 11, 22, 33, 44, 55, 66. And again, that list could go on infinitely, right? Now these numbers do have a common multiple. If you were to take this list for a really long time and cover the whole chalkboard, we'd eventually hit the number 66, wouldn't we? 3 would also eventually get to a 66, though a little bit quicker than the 2. 6, of course, wasn't actually that far away from getting 66, and the 11 already hit it. That's a common multiple. If we were to just look at these two numbers, they have a common multiple of 6. Later, a common multiple of 12. Does that make sense? There's different common multiples. So if I wanted, for instance, the least common, that's an N, I can't write, common multiple of the number 8 and the number 10. Well, we could make a list of multiples. Let's think about our multiples of 8. Class, say them with me. 8, 16, 24, 32, 40, 48, and so forth, right? And let's think of our multiples of 10. These are a lot easier, aren't they? 10, 20, 30, 40, 50, 60, and so on and so forth. All right, where's the smallest number that showed up on both lists, Jalen?
40.
The 40 is my least common multiple, right? Question?
Does that work for 1 also?
For 1?
Yeah.
I mean, one is a multiple of everything. So I mean, 1, 2, 3, 4. I'd be writing a list for a long time, but yeah, technically yes, one is a multiple of all things. What if we wanted the numbers 9 and 15? 9's not too bad, right? We memorized our 9 times table. Say them with me, class. 9, 18, 27, 36, 45, 54, 63, and so on and so forth. How about 15? Now picture a clock, right? Picturing the clock here. 15, 30, 45, 60, 75, good, and so on and so forth. Did you see the least common multiple of these two numbers, Ben?
45.
45 is that least common multiple in that case. All right, but you understand this. That's so inefficient. Mathematicians are lazy. And I don't want to have to make massive lists of numbers to figure these things out, right? There's a better way. Now, why is it important to know a least common multiple? Well, you use these, and you've used them the past several years when you've worked with fractions. You remember when you have to add fractions? Like, for instance, if you added like a 1/3 plus a 3/5. You remember you can't just add these. You have to get a common
Factor.
denominator.
Denominator.
You had to get a common denominator. What would it be for 3 and 5, class?
15.
Because that's the least common multiple. That would be your common denominator. So this, of course, is the obvious application of the least common multiple. Is getting a common denominator later on when we get to fractions in this class. There's a better way, though, to find your least common multiple rather than listing out long lists of multiples, especially if you had some big numbers. I mean, 15 got hairy pretty quickly. 8 was causing trouble for some people, right? There's a better way to find least common multiple. So, flip, if you would, in your textbooks to page 38. And let's look at how to find the least common multiple. First thing we want to do to find a least common multiple is we want to prime factor our numbers. Like Mr. Askey, didn't we just do that for GCF, greatest common factor? Yep, and we're doing it for least common multiple too. We'll prime factor our numbers. So for instance, if we have the number 18 and the number 27. By the way, I think all of you could look at these and immediately spot the greatest common factor, class. 9. These are both on our 9 times tables. If you were to prime factor this, 2 times 3 times 3, 3 times 3 times 3, we can see they both have 2 of those in common. So getting our greatest common factor, or GCF, of 9 is easy. But here's the thing. While we're at it, while we've already got them prime factored anyway, let's find the least common multiple. Here's what we do. Instead of looking for what they share, they both have 2 3s, right? That's greatest common factor. That's what our factors are common. For least common multiple, we're going to have a contest. Right down the side margin there, next to where it talks about the least common multiple, we're going to have a contest. Right there on the side margin of your book. We're going to look for winners. And I always start with my smallest number, 2. Right? That's my smallest prime number. Who has the most twos class?
18.
18. Now he wins by forfeit, okay, because the other doesn't have any twos, okay? It's like the other team doesn't show up for the game like, yay, we won. It seems kind of empty, but whatever, we'll take the win and helps us in our season standings. But it's a winner nonetheless, right? What about who won the threes? Well, 27 has 3 of them. 18 only has 2 of them. Losers, we have to cross out. We get rid of losers, okay? So we'll cross out the couple of 3s. And all we're going to do is we're going to multiply all the winners. So 2 times 3
6.
times 3
18.
times 3. 54. Now, there's a better way, by the way. If you list 2 times 3 times 3 times 3, what's 2 times 3, class?
6.
What's 3 times 3?
9.
What's 6 times 9?
54.
So remember, we don't have to multiply in order. We can kind of pair it up however we want there, because you can go out of order with multiplication. So our greatest common factor is 9. Our least common multiple is 54. Aren't you glad we didn't have to think through multiples of 18? Because we didn't have times tables for that, did we? Look at the next one. This one you could probably do in your head, 10 and 25. Now, we already know the greatest common factor, class, of 10 and 25.
5.
5. We don't need to prime factor to see that, do we? We already know they both have a 5 in them. So greatest common factor of 5, no big deal. Probably we could figure out the least common multiple. Anyone just know it already?
2. No. 5.
Common multiple.
50.
50, right? 10, 20, 30, 40, 50, 25, 50, 75, $1. Remember that? Okay, so 50 is our LCM. We already know the answer to it, but let's suppose we didn't. Or maybe we were stuck in that GCF mode and we're thinking 5. Well, who wins the 2s, class?
10.
10. Winner by forfeit. All right, who wins the 5s?
25.
25. Loser. Cross it out. And there we go. 2 times 5
10.
times 5.
5D.
5D is correct. 50 is our least common. Hey, it's a Monday. I know technically it's Tuesday, but it feels like a Monday. We'll cut her some slack there. 50 is our least common multiple. Does that make sense? All right. Let's suppose we had, write these numbers in the side margin of your book, if you would, please. Let's say we've got a 12, and let's suppose we've got a 20. And we want to know our least common multiple, 12 and 20. Write those down. Well, for 20, think about the prime factors. Maybe do them in your book if you need to. What would be the prime factors of 20? Call it when you've got it. Call it, Luciana.
2 times 2 times 5.
2 times 2 times 5. All right, now the prime factors of 12. Prime factors of 12. Elaine's got it.
2 times 2 times 3.
2 times 2 times 3. Now here's the little problem we run into. Who's the winner of the 2s, class?
It's a tie.
It's a tie. All right, sports fans? Sports fans? Okay. Basketball fans? Baseball fans? Okay, I've got Blau and baseball. Okay, but basketball and baseball, they both really. Okay, I'm going to use baseball first. Okay, because baseball season's kind of in the getting down toward the end. We're getting toward the postseason. My Cardinals aren't going to be in the postseason.
Oh.
They weren't going to be in the postseason 3 months ago. We already knew they weren't going to be in the postseason. It's been a bad season for my Cardinals. Moment of silence for my Cardinals. The disrespect. All right. Anyway, but okay, so y'all have seen this in a game, right? The runner runs in and steps on the base at the same time the throw goes to first, right? Now here's the problem. In that moment, the umpire has to make a call. Now we've got technology, right, where we can do instant replay and all that. But I mean, when I was growing up, there wasn't any of that. The umpire had to make a decision, and what he said was final. There was no challenging it or watching the video in slow. They didn't have all that when I was growing up, when I was your age. So it was just the umpire had to make a call. There were no ties. He had to decide a winner. It couldn't be like, well, he's out and he's safe, so we're going to charge you an out, but we're going to leave him on first. You can't do that, okay? You have to call something. Or in basketball, block charge call. You know what I'm talking about? There's the collision. Somebody has to be charged for a foul. There's 2 guys on the floor. And at that moment, the referee has to make a split-second decision. Are we calling charge going that way, or are we calling a block? And he's got to make up his mind. You know what? He doesn't have a clue either. He's just making it up as he goes along. But you have to pick a winner. We're going to do that in case of a tie. Write that in the notes. In case of a tie, pick a winner. It is completely up to Bryson. Do you want the 12 to win or the 20 to win?
Let's go big, bro.
Go big or go home. The 20 wins. Cross out the 2s for the 12. That's a loser. He's out. Okay? And then circle the 2s for the 20. That's the winner. Why? Bryson said so. When you're the one doing the problem, you get to say which one's the winner. Now, we know the 3 is a clear winner, right? That's an easy one, okay? And now the 5, that's a clear winner as well. But in case of a tie, just pick a winner. Make sense? And then we're going to multiply all our winners. 2 times 2
4.
times 5.
40.
Hey, duh, of course that's 20, right? And then 20 times 3.
60.
3 $20 bills is 60. The LCM is 60. Does that make sense? So you'll run into that from time to time. There will be ties. Just okay, break the tie. Pick somebody to be the winner, cross out somebody who's the loser. Questions on that? Look at the example there on the top of page 39 now. Look at the example at the top of page 39. They've got 4 factored as 2 times 2, or they used 2 squared. They used exponents. 9 became 3 squared, and 12 became 2 squared times 3. Now notice, there's 2 different ones with a 2 squared. Do you see it? The 4 has a 2 squared and the 12 has a 2 squared. You know what they did? They picked the 4 to be the 2 squared. They have compassion on the little guy. Okay? The 9, clear winner with the 3 squared. Now they didn't take the time to cross it out, mainly because it's annoying to cross stuff out when you're typing it, but they could have. I'd have crossed it out. And they took the 3 squared, the 2 squared. Sure enough, 4, 9, 12 all have a least common multiple of 36. And of course, when you hear that, you're like, yeah, duh, of course, they all end up having 36 on their times tables. Questions on that? Yes, sir.
My thing that I keep thinking of, why is the least common multiple large?
Yeah, that's a great question, right? Greatest common factor, and it's little. Least common multiple, and it's small. Here's the key. Don't focus on the words greatest and least. Focus on the words factor and multiple. A factor is a part of a number, right? 20 has factors of 4 and 5, right? You've got a lot of parts, Ben. Fingers, toes, arms, legs, ears. All of your parts are smaller than you. Does that make sense? All of your parts are smaller. So a greatest common factor is still a factor. It's still a part. You just want the biggest part. But a multiple is always bigger, right? Think of bunny rabbits. 2 bunny rabbits don't exist very long. It becomes lots of bunny rabbits. You know what I'm talking about? Okay, lots of, but multiples, right? Multiples of bunny rabbits, okay? Multiples of numbers. Again, what are your multiples of 18? 18, 36, 54, 72, 90. Like, they're all big because multiples by their definition are bigger than the number. Multiples of 27, heaven help us. 27, 54, 81, 108. I mean, they're all big. That's what a multiple is. What you're looking for is the smallest of those multiples, but multiples are already big. Factors are already small. You're looking for the biggest of the factors. So you're looking for the biggest of the small or the least of the big. Does that make sense? So that's why least ends up being big and greatest ends up being small. But it's not because of least and greatest. It's because factor and multiple. Factors are small, multiples are big. Yes, ma'am?
I usually think of multiples, multiply.
Or things, yeah, you're multiplying the 18 by 1, 2, 3, 4, 5, 6, 7, all those different numbers, right? So that's what makes something a multiple, okay? Other questions on that? That was a good question. Good question. Good logical thinking question. At the bottom of page 39 now, we're going to do this box here, and the first one's already done. Notice they factored the 6 into 2 times 3, and they factored the 8 into a 2 cubed. Now, they used exponents. You don't have to do that. They wrote their least common multiple as 2 cubed times 3, and then they took the time to expand it anyway, which is why I probably wouldn't bother writing it with exponents, but you can if you want. 2 times 2 times 2 times 3, they found it to be 24. Now, look at number 2. We got a 3 and a 4. How would we prime factor a 3, class?
1 times 3.
1's not prime. So just 3. All right, then let's factor the 4. How would we factor a 4, Corey, for redemption? 2 times 2. All right, now go through in that thing and circle your winners. Who wins the 2s, class?
2.
The 4.
4.
Who wins the 3s, class?
3.
So what do we need to write in the LCM box? Luciana?
4 times 3.
All the winners get written down. You circled it. Did you circle the 2 times 2 for the 4?
So 4.
Luciana. Okay, let's try this again. Next to the 3, class, what should we have written down?
3.
3. Next to the 4, what should we have written down, class? 2 times 2. We should have circled the 2's because they're winners. We should have circled the 3's because they're winners. Luciana, in the next box, we're going to write down everything we circled.
2 times 3 plus 3.
You change it on me in the middle. 2 times 2 times 3. So, once we've written that, now we'll multiply, Luciana. And what is the least common multiple? 12. Again, your multiples of 3, 3, 6, 9, 12, 15, 18. There's lots of multiples. Multiples of 4, 4, 8, 12, 16, 20. But the smallest multiple that they share is 12. Right? Does that make sense, Ben? Look at the next one. 4. They gave it to us again. How would we prime factor the 4, Sam? 2 times 2. How would we prime factor the 14 right below that page?
2 times 7.
All right. What do we need to circle here, Paige? We're circling our winners. We've got 4 is 2 times 2. We've got 14 is 2 times 7. What do we circle?
2 and 2.
The 2 times 2. What do we cross out, by the way?
2.
This little loser 2. All right, and what else do we circle?
7.
7. So in the next box, what do we write down?
2 times 2 times 7.
And then we multiply it out in class. What is our least common multiple?
28.
28. All right, let's do the next one together as well. For 10 and 12, and did we already do? No, we didn't do 10 and 12. For 10, how do we factor the 10, Michael?
2 times 5.
2 times 5. Next to the 12. Well, we could cheat, couldn't we? Did we already do a 12 somewhere? Huh, in the blue shaded box earlier on the page we did. What are our prime factors of 12, Kirsten?
2 times 2 times 3.
There we go. All right, what do we circle, Ben?
The 2 2's.
And we cross out the
Loser 2.
loser 2. What else do we circle?
5.
And
3.
3. All right, and when we multiply in the next box, then what do we write down, Ben?
2 times 2 times 3 times 5.
Good, got them in numerical order. We multiply them all together, and what do we get, class?
60.
60 is our least common multiple. Again, 10, 20, 30, 40, 50, 60, 12, 24, 36, 48, 60. They both turn into 60 eventually. That's the smallest multiple that they can both become. Questions on that? All right, now for the next page, they don't give us a little box, but you're going to do the same basic process. I want you to do numbers 5 through 8 at the top of page 40. 5 through 8 at the top of page 40. Prime factor, circle your winners, cross out your losers, and then take all the winners and multiply them together. Yes, sir. Yes. Practice showing, because again, they've given you some pretty small numbers here early on, but they will get bigger. But if you practice the process, you're not going to be thrown off when the numbers get big. Remember, if there's a tie, just
Pick a winner.
pick a winner. Pick whichever one feels good to you if there's a tie. Alright, so this is a single 5. That's a 2 times 5. You can't have this as a tie, right? They both have 1 5. One's a winner, one's a loser. This is the only guy with a 2, so he's a winner. He's the only one with a 2. So then we multiply the winner 2 times the winner 5 to get. Once you finish the top row, pencil down, look this way so you know that you're done. You might be noticing a pattern with these. That's not how we prime factor 72. Prime factor it. Yes, ma'am.
Can you put your head down if we finish?
For a moment, just don't fall asleep. Actually, I said it when I was sitting in the chair. You're supposed to look at my chair. There we go. I did say look this way. I didn't say look at me. All right, pencils down, even if you're not done. I will say this first round of examples is a little bit sad. 5, of course, just becomes 5 class. 10 becomes
2 times 5.
2 times 5. There's a tie between the 5s. If there's a tie class, you just
Pick a winner.
pick a winner and cross out a loser that you have selected. The 2, of course, is a winner by default. And when I multiply 2 times 5 class, the LCM is 10. Well, yeah, 5 and 10 can both become 10. Looking at the next one, I got a 6 and a 72. 6 isn't bad at all. What do I prime factor the 6 into, Sam? 2 times 3. 72 is a bit bigger. What do I factor the 72 into, Corey?
2 times 2 times 2 times 3 times 3.
And notice, class, who wins the 2s?
72.
Loser. Who wins the 3s?
72.
Loser. Well, look at everything that's left. It's all the factors of 72. So let's not make this hard. What's the LCM, class?
72.
72. Looking at the next one, 7 and 49. Well, what's the factors of 7, class?
1, 7.
7, right? What about the prime factors of 49?
7.
7 times 7. Notice winner, loser, and once again the LCM is
49.
the bigger number, 49. The same thing happens on number 8, right? The winner of the 2s becomes the 48, and it's the only one with a 3 in it, so it wins that too. So for number 8, your LCM is 48. It's a little disappointing, right? When it's always the bigger number. That's not going to be the case for the next set of 4. I want you to do numbers 9 through 12 now. Do 9 through 12 now at your seats. Again, if they give you a prime number, you don't have to factor it, just write it down. It is its only factor. Make sure you're working, don't just sit there. Several people finishing up. All right, the first set of 4 had a theme where it was always the bigger number that basically became the LCM because look, 10 contains 5, 72 contains 6, 49 contains 7, 48 contains 8. The LCM kept being the bigger number. Here there's a theme as well. 5 class just becomes, well, 6 becomes,
2 times 30.
everybody's a winner. Participation trophies for all. And so we basically just multiply it all together to get class
30.
30. Well, here 7 is just
7.
7. 8 becomes what?
2 times 2 times 2.
But once again, everybody's a winner, and so we just get
56.
56. We're multiplying all of it together. Here 9 becomes class.
33.
Well, 11 is 11. Everybody's a winner, so we just get
99.
99. And here 2 is,
2.
and 9 again is,
3 times 3.
and of course everybody's a winner, and so we just get
18.
18. Notice in every one of these instances, class, they had nothing in common. There were no losers. Because these numbers in each case, class, were
Prime to each other.
prime to each other, class. All these pairs of numbers were prime to each other. And when numbers are prime to each other, you could basically just multiply them, couldn't you? In each case. So if the larger number contains the smaller number, the bigger number is the LCM. If the numbers are prime to each other, they have nothing in common whatsoever. Well, then you just multiply them and there's your LCM. Does that make sense? Now finish the section, do 13 to 18. Now do 13 through 18. And these ones are not going to quite follow that same pattern. There will be some losers to have to deal with in 13 through 18. Done. You're not done because you have to finish prime factor. You can't leave before it's not prime. You got to factor that into right now. That's a winner of all the 2's. There's the winner of the 3's. There's a tie. So you pick one, scribble out the other guy. You multiply all of those together. Just like I showed in class. Take another minute or so to be finishing. Several people in here already finished. All right, pencil down. Look this way. For number 13, how did you factor the 6, Michael?
2 times 3.
And the 9?
3 times 3.
Winner, winner, loser. What's the LCM?
18.
18. Look at the next one. How'd you factor the 15, Kirsten?
15. 3 times 5.
And the 20?
2 times 2 times 5.
All right, winner by default, winner by default. Which one did you call the winner?
15.
Loser. And when you multiplied all that together, what did you get for your LCM? For number 14? Okay, well, let's do it now real quick. What's 3 times 5?
3 times 5, 15.
Times 2. 15 minutes, 15 more minutes? 30 times 2. 30 and 30?
60.
60. There we go. Look at the next one. 12. How do we prime factor it then? For number 15, what were your prime factors?
2 times 2 times 3.
And 16?
2 times 2 times 2 times 2.
Good. Clear winner of the 2s, loser. Winner of the 3s. When you multiply that together, what did you get for your LCM?
48.
48 is correct. For 25, what were your factors, Elaine?
5 times 5.
And for 30,
5 times 6.
that's not prime.
Is
5 times, how would the 6 factor?
2 times 3.
Fortunately, there weren't other 2s or 3s to have to conflict with anyway, so both of these ended up being the winner, so technically the 6 kind of worked, but be careful there. This is a clear winner, that's a clear loser, and so when we multiply all that together, what do we get? Should have been the same answer you had.
150.
Yeah, should have been the same answer either way, just be careful with prime factor. Look at the next one, 10 page, how do we factor it?
5 times 2.
And 35?
5 times 7.
One of these is a winner. Obviously the 2's a winner and the 7's a winner. You pick one of the 5's.
35.
And that makes this a loser. And we multiply, let's say 2 times 5
10.
times 7. 70 is our LCM. For 22, Jalen. Can make this too hard now. Her mind went blank. Corey?
2 times 11.
2 times 11. Jalen, back to you now for 33.
3 times 11.
All right. Clear winner, clear winner. One of these is a winner.
33.
And one's a loser. 2 times 3?
6.
Times 11.
66.
66 is our LCM. How many got all of these? Even if you didn't finish them all, but of the ones of these you did, you had them right. Are there any questions on how to find least common multiple? You're going to practice a little bit with this in your homework tonight. For homework, you're going to do page 37. Make sure you write all of it down. Make sure you check your assignment how to do all of what you write down. Page 37, do 1 through 15. Page 37, 1 through 15. And on page 41, do 1 through 8. Page 41, just do 1 through 8. We do have a test coming up on Friday. That's in lesson 19. Your first chance at the Wall of Fame. So test coming up in lesson 19. We have finished our test material. This was the last new concept. So tomorrow we're reviewing. Thursday we're reviewing. Friday is your test over what we've covered so far this year. All right, have a wonderful rest of your day, and you are dismissed.